Hello everybody. In this series of videos I'm going to discuss how to build your own artificial intelligence, something akin to Jarvis from Iron Man, which can keep your house secure, recognize you when you come home, and can be extended to do whatever you want. Will we develop something to replace Alexa? Not at all. But will you learn how Alexa works along with a bunch of other technology? Absolutely. And we'll actually build some capabilities that Alexa cannot currently do. I welcome your feedback, input and contributions along the way, as I'm no expert in AI or robotics, but I have built earlier platforms, and you can see some old videos of those in the link at the comments. My previous AI had various names, but I mostly settled on Meebo, and as I create this series I'm essentially re-architecting Meebo based on some lessons I've learned along the way. So let's take a look at the architecture that is planned. To design an artificial intelligence, a good place to start is the model of a real intelligence, the human model. Humans have a brain to process information, and various senses which collect information. Based on what we understand, we can then take actions, and actions cover a broad range of things such as pressing a button, replying to a question, deciding it's too cold, or even deciding to do nothing. In the world of electronics, there are many devices which can substitute for our senses. These go by a similar name, sensors. Sensors detect things like temperature, airflow, movement, sound and light. To substitute for the human brain though, you need something to collect the data from our senses, and then also something to process that information to make decisions. In the computer world, for the first requirement, we can use something called a message queue. A message queue will accept the data from a variety of inputs, and then queue the data until some process takes it. To then process the information and make decisions, there's a variety of tools we could use for simple logic, but for something approaching intelligence, you can't escape the fact that you'll need to do some coding. And if you're put off by the prospect of coding, then you needn't worry. We're going to be using Python, which was designed specifically to be easy to understand, and is the perfect place to start learning to code, even for kids. And the cool thing about Python is there's a ton of libraries of pre-built code we can leverage for things like image recognition, language recognition, and so on. And I will be doing the coding anyway, so you can just take my code and run it, or if you want to understand the code or modify it, you can look through my code and learn Python that way, which I think is the best way and how I actually learned to code. For our message queue, we're going to use a product called RabbitMQ. Based on the research I've done, it's very flexible and is commonly used, and there's good integration with Python. As I mentioned earlier, I'm re-architecting my earlier AI named Meebo, and the first step in this process of re-architecting is to introduce the message queue. This lets me add additional computing resources at the edge of my design. For instance, I can have one device running my message queue and brain logic, and another device like a Raspberry Pi operating as a smart sensor. The Raspberry Pi itself can have multiple sensors attached and can decide when to submit data to the central message queue. This is where our AI design departs a little from the human model, but it's very similar to some animals, like the octopus, which can have multiple brains. The central brain does most of the thinking, delegating some decisions to the tentacles. And just like the octopus, we want our tentacles to be able to take actions. So our edge computing devices will not just be sending data to the queue, they will be also monitoring the queue for instructions. I found previously with Meebo that heavy processing tasks like machine learning simply took too long on the Raspberry Pi, or they tended to crash it. So these tasks I'll push to the central brain. I'm therefore going to use an old laptop as my central computing resource, but you could use a Raspberry Pi if you wanted to, especially if you avoid machine learning or use one of the more recent higher powered Pis. In fact, you could run all of this on one device if you preferred. The final element I want to introduce at this point is the concept of context. Each time a human interacts with our AI, it effectively represents a single transaction. For instance, if movement is detected by one of the sensors and the central brain decides it can see a person, then we might respond with, "Hello there." In the likely scenario that the person moves again, we don't want to greet them again and again and again, so we need to store some sort of context so our AI is aware we're already talking to a human. Now that I'm introducing potentially multiple computing devices, I've not yet fully decided how to implement this, but I think I'll store the context on the central brain in a document in JSON format. JSON is essentially a hierarchical document structure which would accommodate recording context for multiple devices. I could go into more detail around things like motion detection, hot word detection, and natural language understanding, but we'll leave these topics for later videos when I actually build these components. This is just the broad overview of how I see things hanging together. I'll be building the various components as time permits, and with my day job and family commitments, there might be the odd break between videos, so if you want to be notified of when the next video is posted, then please subscribe to the channel. Thank you.